Hi, my name is Craig with Apeks Supercritical, and today I'm going to give you a demonstration on our 1500 PSI 1 liter desktop supercritical extraction machine. As with other machines I discussed, we have three components. We have our system. This is where our material goes in and our extraction will take place. And this is where the oil will come out. We also have our chiller down here, which maintains temperature control throughout the entire system. All these vessels are jacketed. That's what these blue water lines are for. Then we have our pump. This controls flow and builds up our pressures where we need them. It also assists with recovery at the end of the run when we're putting CO2 back in the bottle. This system's run parameters are set to run at very popular low pressure, low temperature parameters, where a lot of people, even on the larger machines, still prefer to run at the same parameters that this machine is dialed in for. We offer buyback on all of our Apeks machines, so a lot of people will start with this machine, develop a product and develop their processes, and then they'll turn this machine back in towards a larger machine in the future. Another benefit to this machine that a lot of people like is that it's all 110 electricity. This is 110, you need three separate electrical outlets. 110 for this, 110 for the chiller, and 110 for the pump. We recommend that the pump and the chiller are not on the same electrical circuit. But we've recently made some design changes to this system just to get more thorough extraction and to reduce the amount of maintenance people are having to do to it. We now have a flow switch installed in the system, so it prevents user error. It prevents people from leaving their chiller off and causing all this to freeze over, which then fills the pump full of oil. So that can no longer happen. We've also made some changes with our orifice in here. It is permanent, it's a compression fitting now. There's no more putting Teflon tape on it. Very simple, and there's no remembering, you don't have to remember to orientate the orifice anymore. It's a permanent fixed orientation. We also, our biggest improvement lately on this pump, the seals used to only get about 50 hours. Now we're seeing about 120 hours on seals. Seal replacements, we have a great video on that. And we also have step-by-step instructions in the manual. So all maintenance on this system is fairly easy. It takes maybe 20 minutes between runs, and then every 100 hours, an additional 20 minutes to replace those seals. All right, so now we're going to talk about filling this machine and performing the extraction. If you want, come on over here. I'll show you inside. If you look, it's a fairly small vessel. It'll hold, like I said, a 1/2 to 3/4 pound material. There's a remote probe sticking up in the bottom of it. That is connected to our chiller down below so that we can properly monitor and control the temperatures of our extraction. We provide this funnel for filling here. So we would load the extraction vessel. We recommend drying and grinding your plant material. You'll grind it down to coffee ground consistency, maybe a little finer. Then we provide this funnel to fill the extraction vessel. Then you can also pack some of your material in there to achieve that 3/4 to a whole pound worth of material. Then put your top on here after you've loaded it. Now we're going to install these bolts. We recommend hand tightening them all first, and then we've provided impact with the system for getting these all the way tight. So now that we got these hand tight, all of them are hand tight, we'll use our impact to tighten these in a star pattern, just like we would tightening the wheel in our car. You don't have to hold it, it's real quick taps. And then once around. Now that that's secure, if you want to step back over here. Now that that's secure, so we've got this full of plant material. Now we close. So right here we have 4 different valves. Right now they're all open. This controls flow direction in our extraction vessel. So each run we will change this. So for one run, we will flow in the top of the extraction vessel, out the bottom, into our separator. Then the next run, we will flow in the bottom of our extraction vessel, out the top. The reason we do this is because there's filters at the top and bottom of this extraction vessel that we don't want to get clogged. If we switch the flow every other run, it keeps them clean and maintains good flow. Then we have 2 vents here. So I've picked my flow. I'm going to go and flow bottom to top for this run. Now we have 2 vents, one here that we're going to close. These will be opened at the end of the run to prevent the remaining pressure of the system. So now that those have closed, we're going to open our CO2 bottle. We've already secured this. We want to make sure all these are closed, our separator lines are tight, which they are. Clamps are tight. All of our water lines are properly connected. One of those design upgrades I was discussing won't allow the system to start if all the water lines aren't connected. So even if you forgot to connect one of those water lines, no worries, the system's just not going to start. You're going to come over here and check it. Make sure our chiller's turned on, or like I was just saying, the system's not going to start up. 70 degrees Fahrenheit, 65, 70 degrees Fahrenheit is a good low pressure, low temperature setting for this system. Chiller's on, bottle's open, everything's tight, valves are correct. Turn our system on. There's a little display screen over here that'll tell us what to do. It says press start to reset, so we'll tap that one time. It says system ready, hold start to begin. So we're just going to push and hold this. Now the system's going to fill up. I'm going to come in a little closer. All these gauges are slowly rising. Here in a second, this pump will kick on, and we're essentially done. We're just going to watch the gauges, make sure everything gets up to pressure, make sure the chiller gets the temperature where we want it, and we're good to go. It's probably going to take about 15-20 minutes. Or if you notice down here, this chiller temperature is rising. That's because we've got that remote probe inside the extraction vessel. All that compressing CO2 in there is creating a lot of heat. So this is going to go up in temperature, but we've got our set point set for 70 degrees. So what's going to happen is it's sending cold water through this vessel, and eventually it'll bring that temperature down to our set point. So as I was saying, it's going to take 15 to 20 minutes before all of our pressures are steady and our temperatures are steady. So we're going to hang out the next 15-20 minutes, make sure everything falls into place. This extractor pressure should fall somewhere between 1,000 and 1,250 psi. Right now you can see it's only about 800, 900 psi, so it's still climbing. Once it reaches steady state, it should be between that 1,000 and 1,250. Our separator, we will maintain between 400 and 420 psi. We do that over here with this little green knob. So in the first initial setup, you'll play with this to dial in our pressure over here. Now once we get this dialed in, very rarely do we need to actually mess with this green knob. So while this is building up pressure, we're waiting for it to reach steady state, I'm going to discuss a little bit about what's going on. What's happening right now, we have gas leaving our CO2 bottle. It is coming over here to our pump. Our pump is compressing that CO2. It's sitting about 1,200 psi in our extraction vessel, which is right here where all of our plant material is. At 1,200 psi, 70 degrees Fahrenheit, there's a liquid CO2 running across our plant material in this vessel. It's working as a solvent, so it's going to pull off those oils and waxes, and we're carrying that liquid CO2 with the oils in it over into our separation vessel. Inside our separation vessel, we have a small orifice. I'm going to come in a little closer, take a look at this. This will be sitting here. This small orifice, this little tiny hole at the end of this down tube, is what's holding back 1,200 psi in our extraction vessel and maintaining about 400 psi inside of our separation vessel, at which pressure CO2 is a gas. So that liquid CO2 is coming through with the oil, it's flashing into a gas, the gas is being sent back to the pump to be recompressed, and the oil is falling out into our collection cup. So at the end of every run, after all the CO2 is recovered, we'll take this cup off to harvest our oil. So now our system's been running about 20 or 30 minutes, and as you can see, come on over, our temperatures right down here near our set point is 70. Our pressures in our extractors about 1150, almost 1200, and our separator pressure is around 420. So it's running right now. Everything's flowing. If we had plant material in here right now, there'd be extraction taking place, and it's going to continue to do this for the next 4 to 8 hours, depending on how long we set over here. So we're going to continue to let it run. We're going to leave, come back in another 3.5 hours from now, and we will watch it go into recovery. So now we're back. The system's in recovery, as you can see, going up here. You can see now our pressures are starting to drop everywhere. Our temperature down here is going to get cold. As I said in the beginning, that compressing CO2 in here is going to create a lot of heat. Decompressing all that CO2 as we put it back in the bottle is going to get extremely cold in there. So it's normal for these chiller temperatures to drop extremely low. So we're going to give it another 30 minutes and our recovery should be complete. We'll see you then. So now our recovery is complete. As you can see, all the gauges are sitting around 190, close to 200. So that's as far down as this pump is going to pull down all that CO2. So now what we'll do, our chiller's still on down here. So this is exactly how you'll walk in at the end of a run. We'll turn our chiller off. We'll come over here, close our CO2 bottle. We'll open up our two vents here, vent out this remaining pressure. Go and open up all valves, make sure all pressure is relieved through the system. Everything was reading 0. And now we can take this off, use this, and so essentially the run's done now. We're going to take this off. We're going to use a shop vac to suck out our dry plant material from here. And then we're going to take this off and harvest oil. So here's the impact that we send. So now we can get a shop vac, we can suck out any dry plant material that was in here. We'll come over here, harvest our oil, disconnect this water line. We're just disconnecting the water lines so we can separate this collection cup from the rest of the separator. Collection cup off. And in here, obviously it's empty right now, but this is where our oil would be built up. So you can see there's a little bit of residual oil in there right now. And there could also be hard stuff, 99% pure THCA buildup on the walls, because we do keep this system at low pressure and low temperature. So at that point, if we wanted to get that hard stuff off the walls, we would use this little scraper tool that's provided with the machine. We put a glass dish underneath here and we scrape that hard stuff off the walls and keep that separate from our oil and wax that's in here. We can make shatter with that hard 99% pure THCA buildup that is on the walls. So we would take this now over to our little workstation and harvest our oil into a beaker or a glass dish of some kind. Then what we do, after it's clean, we come back over here, reassemble everything, reload plant material, and go back through a startup. If you have any questions regarding what I just discussed, or if you want a demonstration on any of our systems, we offer live demonstrations here in our Denver office. You can contact me, Craig Henderson, at craighh@apexsupercritical.com, or you can schedule your demo with Tina at tinah@apexsupercritical.com. Thank you very much.